get started. So once again, welcome everybody and appreciate your time, especially evening at 6 o'clock. It's not easy to attend another webinar, and I really thank all of you for joining today. So let's look at what is this event all about. So some of you might have heard about Sony's purpose. So we want to fill the world with emotion, to the power of creativity and technology. So to support Sony's purpose, we have many projects, many initiatives, and one of them is Yuru. So we have had conducted Yuru in other regions, especially Japan. And this is the first time we are hosting this event in India. And this is named Yuru Musical Instrument Hackathon 2023 India. The event is going to be conducted at Bangalore on 11th and 12th March. If in case you have any questions specific to the event or related aspects, please reserve your questions. We have a dedicated Q&A at the end of this webinar. So we will address all your queries in the Q&A. So let's look at the purpose of Yuru Musical Instrument Hackathon. We want you to create music that you love to play and enjoy without any inhibitions. Basically, we don't want you to be a trained musician to really create music. So how do we really do this? By creating simple to use musical instruments. And Yuru Musical Instrument Hackathon is providing that opportunity wherein anybody above 18 years can come on board, join the hackathon to create musical instruments for casual music lovers to play alone or in a group. And what is a Yuru musical instrument? They are basically musical instruments that anybody can play easily. And this is as envisioned by World Euro Music Association. So this World Euro Music Association's motto is to make music kind of playable by anybody, kind of composed by anybody without having prior training or schooling in music. There are a few mandatory conditions to take part and create a musical instrument in this hackathon. The instrument that you create should be playable by anybody without any prior knowledge of or training in music. And a set of desirable conditions. By using your instrument on a regular basis with more practice, the user should be able to get better with it, and also being able to control the scale of music. Now let's look at who is organizing this event in India this time. This event is sponsored by Sony Music Entertainment Japan and co-sponsored by Sony India Software Center Private Limited with Sony Semiconductor Solutions Corporation, Sony Group Corporation, and IIT Madras. And this event is going to be conducted by Sony India Software Center Private Limited. The Yuru Musical Instrument Hackathon Committee is formed by a group of members from Sony India Software Center Private Limited with a set of members from IIT Madras. Of course, being a hackathon, we have to recognize your efforts, your contributions, right? So this is about that, awards and recognition. So we have a first prize worth INR 100,000 and two second prizes worth 50,000 each. INR 50,000 each. And besides this, we also have a set of special awards from our guests, our sponsors, in terms of Sony goods and products, different Sony products. So one award is sponsored by Sony Music Entertainment Japan for one team. Sony Semiconductor Solutions is sponsoring another award for another team, who is again at one of the toppers in this hackathon. Sony Group Corporation is sponsoring two awards. Again, will be given to two top teams in this hackathon. And apart from this, we are also distributing certificates and prizes for teams qualified for this hackathon. So I'll discuss about explain how the teams are going to be qualifying for the hackathon. in later slides. Coming to the phases and timeline, this event, we have launched the event in January this year. We made a press release on 12th of January, and the Ideathon phase, which is the first stage of this event, is scheduled from 12th Jan to 6th February. During this period, we expect interested participants to form teams and register at Sony India Software Center code.in events.html. If you go to this page, you can see all the information about Yuru Musical Instrument Hackathon India. And there is a registration, a link over there. Please click the button and you can fill up the Microsoft forms with all the details of your team. But beyond this registration, we also want you to submit your idea sheet. So once your team is registered, please download the idea sheet template from the website. Fill up the details about your team, your idea, and all the other aspects. There are a set of questions in this idea sheet. Please fill up all the details carefully and then save the Word file, the template as a PDF document and send the PDF document to a particular email ID, which I'll be talking about a little later. So once we received all these ideas from the participants, there is an evaluation panel who is going to be judging these ideas. And based on the merits of this idea, we will shortlist 10 ideas. Subsequently, we have a pre-hackathon phase from 7th Feb till 10th March, wherein to all the 10 teams who are qualified for the hackathon, Sony will be shipping devices. So I'll be explaining what sort of devices later. Sony is providing a set of Sony devices and gadgets to enable your development of musical instruments. And these devices will be shipped to the address filled up in the forms. And teams to also get hands-on with these devices. So we are giving you some time to get familiar with these devices. And apart from this, we expect the teams to start designing your musical instruments and build hardware and software modules before you actually come to the physical venue of the hackathon. So this is the period for you to really get familiar with the devices and also to build your knowledge about it, design, and then create software hardware modules which will be integrated at the hackathon. And the final stage of this event is the hackathon itself on 11th and 12th of March at Bangalore. We will have a venue at one of the happening spot in Bangalore, and we invite all these 10 teams to bring the devices that they have received from Sony along with other modules that they are integrating to build the actual prototype of the musical instrument. And this musical instrument will have to be demonstrated to a judging panel at the hackathon venue. And then you'll have to go on stage for a live performance, a music performance with your devices. And there'll be an award ceremony as part of the closing function of this hackathon. We have eminent guests joining us from Sony group of companies in Japan, as well as very special guests from IIT Madras. So now let me take you through some of the glimpses of past Yuru hackathon events. So we did conduct Yuru Musical Instrument Hackathon in Japan twice, in Tokyo in 2021 and in Osaka in 2022. So if you visit this URL, you can get all the details about the past events, including the sample videos of some of the instruments the participants had created as part of the musical instrument hackathon conducted in Japan. So now let me take you through one such this particular website to show you a few of these samples, a demo of musical instruments, just to give you an idea what is possible with Euro musical instrument or what kind of instruments you may want to build. So give me a second. I'm just switching my window to the browser. Give me a second, please. Okay, so the first instrument that one of the participating team in Sony musical instrument, Yuru musical instrument in Japan created was a type player. Basically, they have interfaced the conventional standard keyboard with a PC and then converted this keyboard to a kind of a keyboard for the music. So let's take a look at the kind of video of this particular instrument they have created. Okay, so that's the first instrument. Now let's move on to another video wherein this team has created a very interesting musical instrument with a wearable device. So this is called pause guitar. So let's now see how this pause guitar works. All these are simple to use musical instrument. Anybody can play this. In fact, in this video, a little small boy, a very small kid, is trying to play the music. Just see. Let me stop the first video, otherwise you might not get the sound from the second one. So in this video, as you see, this boy is trying to play with the wearable device in different orientation, different movement patterns. With this movement, the music is created. With the help of a wireless link, the device's position in terms of an IMU sensor is captured and sent to a music playback instrument, which we will see in a little later. And the music is synthesized over there based on the IMU data values. So it's a very simple to use music device. So this actual creator playing the same instrument. Interesting. So let's now look at the third sample. I will just show that and then we'll move back to the presentation due to time constraints. However, this site is kind of accessible to everybody. And I'll be posting this presentation to the Yuru musical instrument hackathon website. You may please visit this page. This is called Yuru music instruments page. You can have a closer look at all the demo videos here. Now the last sample. So this is another interesting case. They're creating music from glass. It's called chord glass. And again, these are some of the ways in which the participants have created music. Maybe for our interest, we can have a look at another video, one more. And this is a saxophone, but not a very complicated one, not the usual saxophone, which demand you to have deep knowledge in music. This is a very simple to use, just based on your blowing into the saxophone, different music notations are created, tones are created. So let's see how this instrument is being used. Yeah. Okay, so this is how the music is created, and simple to create, and much to enjoy. So this is the objective of Yuru musical instrument. So these videos are available in the site. I request you to please visit this website and have more experience with this different musical instruments the participants have created for the earlier instrument hackathons. Now let's move back to the presentation. I'll take up questions at the end, as I said. So let's very quickly switch over to the presentation material again. Okay, so now we have seen some of the sample musical instrument, these participants had used, have created, and they were able to create nice to hear music, right? Now the question is how to build such musical instruments for Yuru. We're not talking about complex musical instruments. We're talking about simple to use musical instruments for anybody who can, just spend some time. So there are a few hardware devices that Sony is offering as part of the hackathon, which you may be able to use to create a musical instrument. So some of them are listed up here. So first of all, we are providing Spresense, which is an edge computing platform, a hardware, which is housing six microcontroller based, it's a microcontroller with six processing core and a toio core cube. Again, another device from Sony for edutainment. And a third device is called Mesh. So the mesh and the toio are typically for the non-programmers who doesn't know programming languages, but still you have certain logic which you can implement through a visual programming tool like Scratchy or Blocky. So we have a visual designer application available for mobile devices on smartphones and tablets with which you can create logic for mesh. Similarly, there is a web application to create logic for toio. So these devices are offered along with Spresense to create your musical instrument. So in a short while, I'll explain how do we do this. And these devices are provided to you for absolutely free of cost. The only condition is once you complete your prototype building and demonstrate the device, you will have to hand over these devices back to Sony after the hackathon. Besides these devices, we would also allow you to use any other hardware modules components of your choice. For example, let's say you have certain affinity to a third-party hardware module or an open source module, or a custom module that you have designed, you're most welcome to use that and create your musical instrument. However, the cost incurred in creating such or procuring such modules or designing such module will have to be borne by the participating team. Now coming to a very basic prototype skeleton. So how does it look like? So as you know, for a musical instrument, which is very simple to use, it's a very basic, a design. So you have to have an interface to feed your vocal, which is your mic. Then you have to have a signal processing and audio synthesis mixer unit, which takes care of all the audio signal processing. And there must be a IO and connectivity plus core logic wherein your application is really, doing all the magic. And this is the module to which your sensors are interfaced. So I will explain what kind of sensors soon. So we can use either wireless sensors or wired sensors. And the connectivity again, up to you. For example, if you're using some of the Sony devices for connectivity, you may be using Bluetooth low energy. But if there are custom sensors which you want to use for this prototyping, you're free to use any other protocol, standard protocol, which you can interface with the microcontroller based, the signal processing unit. And apart from that, there is an optional actuator component. Probably, certain music when you play out, you might want to do some actuation of a toy or a doll, right? So you can actually do that with a set of actuators. And of course, a speaker is your audio output device. So the speaker also should be attached to the output of your signal processing block. Now let's look at how Sony is going to be augmenting your experience experimenting with this musical instrument with our own devices. So first, we will provide you with Spresense, and Spresense is going to be playing the role of your signal processing, audio synthesis, and mixer block along with your IO and connectivity and core logic. So Spresense has the capability to kind of support both these functionalities. Of course, Presence is not alone. We are complementing Presence with our own custom design sound processing library called ssproc-lib. So sound signal processing library is a new innovation from Sony. There's a very lightweight library which will be running on this Presence and exposing a set of basic APIs, easy to use APIs through which you can drive the signal processing algorithms to create MIDI tones, which are the standard, you know, protocol for any musical instrument, right? So the MIDI tones are generated through the ssproc library, and this waveforms can be directed to a DAC and to a speaker. The DAC is part of this presence, the digital to analog codec. However, the speaker is an external module which you have to interface. And speaking of the speaker unit, you may have to use an actively powered speaker. So we are looking at possibility of providing some USB powered speakers for this hackathon participants. And in terms of mic for the vocal input, you can use digital mics, which can be interfaced on Presence board. So we have a set of digital mic ports available on the board. And again, this vocal input is optional. If you can synthesize music with just sensor input, even that is acceptable in the hackathon. Coming to the sensors, what sort of sensors we can use? Let's look at some example. So mesh is one of the sensors which probably you might want to use. This is Sony's offering. So you can take a mesh device and then use it in this musical instrument as your external sensors. And I'll be explaining more about mesh in the next slide. So mesh usually talks over the Bluetooth low energy protocol. So between mesh and the presence, you will have to establish a BLE link, and mesh will act as the peripheral device of the BLE, and your presence will be, or this block here, the IO and connectivity block will be the BLE central role. So these are the two roles we have to keep in mind and design your logic accordingly. So the mesh is already a peripheral device which is discovered by smartphone kind of central devices, and we are able to get notifications and indications from mesh today. And there are a set of sensors here. It's a bundle of sensors. We have a button, we have a brightness sensor, and so on. I'll explain more about it later. And now the question is, what's the role of the other device, Toyo Cube? Toyo is a big device bundle. It comes with cube rings, you know, cartridges and so on. But for this hackathon, we are providing only the cube part of it. And the cube can play the role of either an actuator because it's got some motors down this area, and it can move around on a surface. And at the same time, it's got some IMU sensor with which you can kind of detect its position or orientation in 3D space. So with this, you could actually use a toy also to generate some sensory perception with which you can run your musical logic here to create music by audio synthesis. So now let's look at the hardware modules and interfaces in detail. So as part of Spresense, we will be offering the devices that are circled here. So we will give you the main board, which is the main compute core of Spresense. Along with that, there is an extension board for, typically for any microcontroller, we need a breakout board for exposing all the analog digital inputs, outputs. So this is the board that plays that role. Along with that, there is a camera. So the question is, why should we have a camera? Interestingly, Sony is not expecting only a keyboard or a sensor to really provide sensory perception to the musical instrument. You could have visual inputs as well, right? So for example, let's say I do some gestures on the camera. I show some colors or certain patterns to the camera, and based on these inputs, the visual inputs, maybe I'll be able to play some good music. So my MIDI tones can be dynamically picked up based on the input that I'm feeding to the camera. So that's a purpose of camera. So maybe without any other sensor, if you're good at image processing, or if you're good at neural network models, lightweight neural network models for talking about deep neural network, which can understand certain images, then you can actually use that itself as your sensory input. And interestingly, this board is pretty powerful. It's got a neural network accelerator support. So we can actually deploy a lightweight neural network model also on this board. And based on that inference, you could provide certain cues to the musical instrument logic to appropriately play the MIDI tones. So these are the possibilities that we are looking at. Again, the speaker and mic, of course, we have to connect them externally. We are not, it's not part of this Presence offering. However, as part of Yuru musical instrument, we from the committee is looking at the possibility to sponsor these as well to the hackathon participants. Now the question is, some time back I said you can actually use third-party modules, sensors, actuators, and so on. So what kind of sensors and actuators? So we say pretty much anything that you are familiar with, anything that is not very expensive, which you can afford, can be integrated to this microcontroller. And then if this can play the role of a sensor or an actuator or a connectivity module, yeah, why not? Please go for it. Now, a very quick look at what is Presence software stack. How does it look like? It's a very deep software stack. It's got we are running an RTOS called NetX on Spresense. So now, due to time limitations, we cannot go into the nitty-gritties of this architecture. However, the recommendation from Sony is please use your Arduino IDE. I'm sure most of you are familiar with Arduino, and you would have done Arduino Uno or Arduino Nano kind of programming of those boards, and you're familiar with the simple to use mechanism, the constructs of Arduino. So with that, you can develop applications running on Presence, and that is going to be a logic. Even the SSProc library that we are offering for free, which you can download from a GitHub link, can be deployed on Presence. And again, these APIs are exposed in Arduino style. So if you are writing an Arduino application, you can invoke SSProc library APIs for creating music with the signal processing algorithms. And this SSProc library will help you to synthesize MIDI tones. So the top graph is kind of showing a pipeline of data. So your sensor input, which is fed over wired or wireless sensor, which is connected to this Presence microcontroller, will have the data about what sensory perception. For example, let's say you interface certain buttons, a keypad with Spresense, and it can actually develop. It can actually play the role of a button drum, right? So you interface this keypad, and this input will be fed to Spresense, and this scan codes will be used as a filter or a condition to generate the appropriate music by synthesizing MIDI tones. And synthesizing MIDI tones is completely abstracted from you. All you have to do is fire a set of APIs. Now let's look at have a glance at Mesh. So Mesh is unlimited inspiration with infinite creations. For more information about Mesh, please go to meshprj.com. There is Japanese as well as English versions of the documentation. Please visit the English version. You have the URL here. So once you get this uh, document, this presentation material from our website, please visit this page and learn more about Mesh. So Mesh is essentially providing you with multiple sensors, as I mentioned. You have an LED sensor. Sorry, LED is an actuator to create some different color. It's a multicolor LED. You have a button, which is a sensor. So it's got multiple, single click, double click, and so on, different events. And you have a motion sensor. Let's say you move closer to the device or move away from the device, the motion sensor can detect that. And then you have a move sensor, which has got an IMU sensor built in, with which you can do a shake action or maybe flip in different directions. And these orientations are understood by this gadget, and the appropriate notifications are sent from this peripheral, BLE peripheral, to a microcontroller or a microprocessor playing the role of BLE central device. And there is also a brightness sensor, which kind of sense the ambient light variations and reports those values. Apart from that, we also have a temperature and humidity in case you are working or you have an imagination of creating a musical instrument which is based on humidity and temperature conditions creating certain music. For example, on a rainy day or when rain or water droplets fall on a particular on the sensor, the music is generated, right? And a GPIO. This is for a little more advanced users. In case if you want to really take input from a different microcontroller board or a module, or in case you want to drive certain modules through a GPIO output, you can use this as your physical GPIO connector and then talk to this module over BLE wirelessly. So these are the various sensors and actuators bundled in Mesh. And these are the features available in terms of what is supported in Mesh. It also got cloud connectivity, but for this musical instrument hackathon, we are not really looking at it. Now glance at the toio instrument, the toio core cube. So please visit this website. We have a very elaborate documentation about toio. Most of it is in Japanese. We will very soon share the English versions of this documentation on our website. Again, toio speaks Bluetooth Low Energy. It's a robotic toy, and it's got the ability to detect position, absolute position, on any surface that it moves around. And it's got high precision control. Basically, you can send commands to control its position as well. And currently, we have JavaScript versions of an application, web application, which you could actually try out to control the toio cube. And there is also a Unity SDK for graphics programmers in case you're planning to do something with Unity. Now, we invite everybody to take part in this wonderful hackathon. This is the first time we are doing it, and there's a long way to go. Our dream is to create a Yuru musical instrument community in India. And for registration and information, please visit Sony India Software Center co.in events. And for your idea submission, please send your PDF documents of your idea, which is filled in the idea template, which we have shared on our website, to this email ID, ideathon-euroindia-2023 @sony.com. And in case you have any support queries about the hackathon or any technical questions about Spresense, toio, or mesh, please write to us at support-euroindia-2023 @sony.com. Now, let me also show some video of demos that our team in India has created based on the SSProc library. So just to give you a feel of how sound signal processing library on Presence board works, this is actually a very simple application. This is the first one. The first demo is going to be about a button drum. So we converted a keypad interface Presence to a button drum. So when you press on certain keys, the MIDI tones of the drum is generated from
अरे क्यों
SSProc
क्यों
library.
क्यों क्यों भाई मैंने उसके आगे भी
I
रख
think
दिया था
somebody's
जो
mic is on. If you could just mute that mic, would really appreciate it. Yeah, thank you. And the second demo is a voice pitch changer. When you feed your vocal input, let's say you hum through the mic, the SSProc library has been programmed in such a fashion that it can generate a tone which is same as your pitch of your tone. And finally, an FM synthesizer. This is more of a capability demonstration. So we have tremendous capability on Presence audio core. It supports high-res audio playback, and it has got multiple mic inputs, analog and digital. So we want to just showcase the signal processing capability of Presence. For that, this particular application bypasses SSProc library that we speak about and directly goes to the metal. When I say metal, the signal processing algorithms are directly invoked with a set of waveforms matrix and the scale metrics that we have in the code. So the entire music is generated from program, the code itself. So now let me play these videos and after that we'll go for the Q&A. So give me just 1 minute. I'll set up this video demos. OK, so we start with the button drum. Please tell me in case if the audio is not clearly audible. So what you see here is a Presence board interface with a keypad. And an external speaker, which is USB powered. And this is the Arduino code. And we've already pulled the SSProc library into this project. Now the firmware is built and the SPK, we call it SPK, the SPK gets flashed onto the board. All right, so that's the first demo. Now let me take you through the second demo, which is the voice pitch changer. So as I said, the artist is humming through the mic and the SSProc library running on Presence is automatically changing the pitch of the tone. Again, the setup is shown here. And for this, we have to interface the mic. So this is the mic interface. This is a digital mic. And now on the USB cable for powering up Spresense. And then on the Arduino IDE, the source code is loaded. And we're building and flashing the source code onto Spresense.
I understand. Sound is not come from the our side.
Oh, sorry. I think maybe 1 second. Let me just reshare again. Sorry about it. Let me try again. Yeah, please tell me if the audio comes a little later. Now there is no audio.
Still, there is no audio.
Sure. No, no, the audio is not started yet. When the humming starts, please listen and tell me. Does the audio come?
No, no.
No one.
No.
It's not there.
No, not cannot hear audio.
Okay. So let me try.
Yeah, now it's coming.
It's coming. Okay. Yeah. Okay. Sorry for that technical snag. Now let's play the last video, which is the FM synthesizer. As I said, this video, this particular demo is not created using SSProc library. This is more to showcase the capability of Spresense. So if you are a good signal processing programmer, you know DSP programming, then you can actually use these as a sample to create your own music effects. Again, this does not really use any external inputs, but you can always tweak the code to feed sensory inputs, external sensor input, and then play the appropriate music. So again, here we have a presence board and it's powered and the speakers are connected here. So this is plain music synthesis from the code. I hope the audio is fine. Are you able to listen, hear the audio?
No, no audio.
No? You're not getting the audio, is it?
Not good.
Okay, let me try again. Now? Is the audio fine? Are you able to listen?
Yes, yes.
Yes, we are getting now.
Maybe that part I'll play again. Showing you the LEDs blinking to the rhythm, same in sync with the rhythm. So this is just a sample. So this actually gives you some confidence on this board. So in case if you are familiar with signal processing and the algorithm, you could actually try out your own approach to create good music based on the external sensory inputs. So that's all we have from the demo side. And now let's go back to the presentation material. So now I'm open for Q&A. So I would suggest you to go after taking your slot. Maybe you can just raise your hand and then we'll start with that. I think I see a hand. Please go ahead.
Yeah, Anil, Vivek here.
Yes.
So what should be the team size? Any limitation?
Yeah, we are looking at a size of team size of 2 to 4 members. We need minimum 2 members and maximum 4 members.
Okay, thanks.
Thank you.
Hello, Karthik here.
Hi.
Hi. So my question is that can we offload the calculation to some other device, or we have to do all the processing on the Spresense itself? Let's say I want to run a neural net. So can I offload that particular computation on some other device and do the remaining computation on
Yes, I think it's
Spresense?
perfectly fine if you want to really use another device as a coprocessor
Yeah,
for
let's
your
say I want to interface with
neural
the
network. Yeah.
laptop for something, some vision related thing, and can I run the network on that? And
Yes.
okay,
Yes,
okay,
perfectly fine. And then you're going to be feeding these inferences to his presence for music synthesis. Is that what you like to
yeah,
do? Yeah.
something. Just I'm just
Yeah, perfectly
trying to
fine.
figure
I
out
think
things. Okay.
you would have, I mean, maybe you have seen that video from Yuru Hackathon in Japan. They did not use presence at all or any of these devices. They have used a plain simple keyboard and a PC or a laptop
Mm, mm,
to convert that into a musical instrument.
mm.
So it's perfectly fine.
Okay.
Uh, please go on. I think we have some more people.
Anil, this is Raghu.
Yeah, there you go.
Yeah, the link to SSproc library where we can beforehand get the APIs and understand how they work.
Oh, perfectly. I think we will be uploading the details to the website
Oh,
very soon with a link to the
oh,
GitHub project. Yeah,
all right. Thank you.
thank you.
No, you can speak here.
I think your voice is breaking.
Yeah, hi. So I just want to clarify what you said. So using Spresense board is not mandatory. Is that right?
Yes.
Okay.
Presence is desirable, or any Sony device is desirable, because end of the day, Sony is conducting to promote these devices. However, if you think your algorithm cannot fit into Presence because it's got certain limitations in terms of memory, for example, it's got only 1.5 megabytes of SRAM. So if your logic cannot be fit inside that real estate, of course, you can go for a different device.
All right. So it's just an instrument which makes some sound or music is that matters.
Yeah, what matters here is the idea, the creativity, and how easy your music instrument to be used by a novice user who has no idea about music.
All right. Got it. Thanks.
Yep.
Hey,
Yeah.
hi.
Hi.
Ashwini this side.
Yeah.
I was just checking the template and I just wanted to know uniqueness part. Uh, can we have just like uniqueness in the software development? Would it be that fine, or do we need to have like in hardware also?
Maybe the uniqueness is not software or hardware. It's only the uniqueness in the thought. For example, your idea, you feel it is unique. Probably you may not have time to do any prior art research. I think it is still acceptable. So if you can highlight what is something that you find unique about your idea, that's something you might want to write out there.
Okay, got it. Thanks.
Yep.
Yeah. Hi, Anil. This is Sridhar here. We have basically I have not explored Spresense at all. So I have used Raspberry Pi as well with the Intel SDK for the neural network, that GPU. So can we still use that, or should we use Spresense or
Please go for it. I think I would love to see your implementation with Raspberry. It's fine. Yeah.
okay, sure, cool. Thank you so much.
Yeah. Any other questions? We have some time. We have about 6 minutes.
Anil, somebody in chat was asking from when the device will be shipped.
Soon after we close the registrations and complete the evaluation of the ideas, I think we take about a day or two to go through the ideas submitted and then evaluate, come up with the short list. Soon after that, we will start shipping devices and you will be receiving it in within 2 to 3 days, depending on where you are from. So if you are in Bangalore, most likely you will receive the devices on the same day. But if it is location is somewhere else, probably it depends on the logistics. Any more queries?
Sir, is there any age limit for this, like for participating in this hackathon?
Yes, I think in the first part of this presentation, we spoke about it. Sorry, I wouldn't have spent enough time there. So ideally, we can have anybody joining, including school students, but based on the internal, decisions, they have restricted this to people above 18 years. So if you are 18 years and above, you can participate in this event.
Okay, sir.
Thank
you, sir.
Thank you. Hirano-san.
Regarding the award prize, so sorry, I mistake to write. The first prize is 50,000 Indian rupee, and the second prize is 25,000 Indian rupee. That is the correct information. Sorry.
Okay, sorry, there's a typo there. There's a typo there. Apologies for that. So we are announcing 50,000 INR for first prize and 2 second prizes, 25,000 each. And there are more goodies and in terms of products from Sony. So you have still a chance to win a lot of prizes on the day. Thanks, Hirano-san.
More one person raise a hand.
Yeah, I think Vivek has actually asked the question, I believe. See Vivek's hand.
Yes, I already asked. Yeah, sorry.
Yeah, right.
Anil, I have a question. Vijayalakshmi
Please.
here.
Yeah, please.
So in your slide, the prototype skeleton, you have mentioned the I/O connectivity plus core logic is connected to actuators. Should the arrow be otherwise, or is this the way that you
Oh, one
are
second. Let me
mentioning?
just check if my diagram has mistakes. Maybe. Um, Thanks for pointing out. Let's go there. Okay, so here, okay, the commands are driven to the actuators, right? So the direction is basically the flow of the command or data.
Okay.
Yeah, yeah. So you're sending the commands to drive a motor, for example. But in this case, you still have a very good observation. This can play the role of either a sensor or an actuator. So ideally, this arrow should have been double, both sides.
Okay.
Yeah.
Yeah, thank you.
Thank you. Okay, any more questions? We have 2 minutes, 2 to 3 minutes here. So I request all the audience to please register your team at the event website. The details are in this document. We will be uploading this document and the recorded video to the website most likely tomorrow. And then you can refer all the information. Apart from this, will also be uploading all the technical details about Spresense. So if you go to Spresense website, maybe we have 2 minutes left. I'll quickly take you through the Spresense website, which will kind of give you a comprehensive documentation of Spresense, and that's going to be a starting point. So maybe let's very briefly have a look.
And meantime, one more question. If we have any difficulties in using the Expressens, will there be anybody who can support from?
Oh, definitely. I think we have a team.
Okay.
So we will support you. Me and my team will support you on your queries on Spresense.
Okay, yeah, thanks.
And Spresense is an open source device, both hardware and software. And there is a very active community around Spresense. So if you go to this site that I'm showing here, this is a dedicated website for Spresense. All the documentation pertaining to this platform is available here. So if you go here, you have development guides, developer guides for both Arduino as well as the low-level NetX API from Spresense. So you go to this section, Spresense Arduino. There is a getting started guide, which will actually give you a jump start. And in case if you have any questions, you can always reach out to me or my team. You can message me directly, maybe email or on the support query email ID. You can post your query, and we will respond you pretty soon. Apart from that, there is also a community here. So if you go to Spresense homepage, you can actually visit the FAQ page for all the details. And down here, there is a Spresense support, and you have a FAQ page, troubleshooting, and a Spresense forum. You could register yourself as an interested developer here. And once you register, you can log into this and then see all the previous posts, the archives, as well as you can post your queries. And this is a community wherein a lot of experts from Sony and third-party companies, open source world are actively contributing. So this is one, kind of a Bible for you for persons. I hope your answer is, your question is answered.
Yeah, thank you.
Thank you. All right, I think we are just done with the time. So thank you once again, all of you, for joining today. I hope it was informative. And further to this, if you have any queries, please send in your questions to the email IDs that I mentioned. I'll be sharing this presentation document in our website. And please visit the website at Sony India Software Center .in at events page. You can find all the information about the India edition of Yuru Musical Instrument Hackathon. With that, let me conclude. Thank you once again. Have a wonderful evening. Thank you all. Bye-bye.
Thanks everyone. Bye.
Thank you, everyone. Bye.
Thank you.
Thank you.